From the very edge of our solar system, a comet speeds towards Earth. It cuts through the atmosphere and plunges into the Pacific Ocean near San Francisco, creating a blast more powerful than any thermonuclear weapon.
Anyone who's outside would essentially be vaporized almost.
It causes a mega tsunami that devastates America's west coast.
Most of the cities along the ocean would be wiped out.
Over billions of years, comets have struck our Earth countless times. And it could happen again.
If it's a large comet, frankly, I'm not sure we could do anything about it.
Through history, comets have been seen as bad omens. People believed a comet heralded the assassination of Julius Caesar, and another foretold the Black Death in medieval England.
During the Middle Ages, comets were thought of as warning signs, missiles shot at a sinful Earth from the right hand of an avenging god.
Some cultures depicted them as blazing swords, slashing the nocturnal sky as an expression of divine wrath. But by the 17th century, astronomers were beginning to understand the true nature of comets as physical objects rather than supernatural creatures or apparitions. Using Isaac Newton's principles, astronomer Edmund Halley calculated the orbits of 24 comets.
Halley was the first to note, along with his colleague Newton, that comets are celestial objects. They're in orbit around the sun just like the planets, except they're on very elongated orbits, so they can cross the Earth's orbit once on the way in and once on the way out.
Halley boldly announced that 3 of them, seen in 1531, 1607, and 1682, were in fact the same comet on its periodic visits to Earth. He predicted that the comet would return every 76 years, and he was right. Halley's comet did return in 1758, as it has done roughly every 76 years since. Halley's discovery altered the status of comets, from mystical omens to real and physical threats.
The fear of comets was sort of transferred from a sign of an impending disaster, some sort of an apparition, to objects that actually could hit the Earth. So we went from warning shots to actual missiles.
One of those missiles might have changed the world 4,800 years ago, and experts think that another deadly missile could strike the Earth with very little warning. Since its birth 4.6 billion years ago, Earth has been pummeled by thousands of comets and asteroids. Scientists think that such impacts may have caused at least 2 of the 5 global extinctions. The most recent, 65 million years ago, is thought to have killed more than 75% of the living organisms on Earth, including the dinosaurs. These major cosmic strikes seem to occur at very long intervals.
The time between impacts depends very much upon the size of the object impacting. For example, an object a kilometer in diameter may hit once every 10 million years, whereas objects 10 meters in diameter might hit the Earth a couple of times a week.
But some scientists now suggest that during the last 10,000 years, the so-called Holocene epoch, Earth may have suffered a series of more frequent, large, catastrophic impacts. They argue that if a number of newly researched geological structures can be confirmed as comet impact craters, this would indicate that comets have struck Earth more frequently than previously thought, and that we may be due for another devastating impact.
If we are able to prove that we have this many craters within the Holocene, it implies that there should be a large impact on the average of about every 1,000 to 3,000 years. And so we should have another impact within about 1,000 years.
To date, scientists have found only about 170 impact craters on Earth, of which only 2 were caused by substantial strikes within the last 2.6 million years. Finding more large impact craters could indicate that a major comet strike within the next millennium is possible. Dr. Bruce Massey and his colleagues think that recent large craters are to be found in the oceans.
Currently, there's over 170 known impacts that have been absolutely validated by physical methods. Of those impacts that have been documented, there are none in the ocean, and yet the oceans cover more than 70% of the Earth's landmass. So we are missing a large percentage of recent impacts because they occurred in the ocean.
According to Doctors Abbott and Massey, one of those missing impacts may have happened 4,800 years ago. They believe that its catastrophic effects could have inspired the story of the Great Flood, found in the Bible and other accounts. Throughout the ancient world, different cultures, from Europe and Asia to the Americas, had legends of a great flood.
Because we only have truly one universal myth, that's the myth of the Great Flood, it was my hypothesis that perhaps it was evidence of a globally catastrophic event.
According to Dr. Massey, this globally catastrophic event may have been the impact of a comet crashing into Earth. Many of the legends describe supernatural creatures or fiery objects appearing in the sky around the time of the flood.
Sometimes these things are described exactly like comets, as flames in the sky, but at least 33 of these myths talked about creatures that were suggestive of a comet.
Dr. Massey sees further evidence of widespread disaster in a series of global changes that occurred 4,800 years ago. At that time, advanced societies were already developing in many parts of the world.
This was already the time of the first dynasty of pharaohs living in Egypt, very advanced civilization.
Then, around the year 2800 BC, there was a series of sudden climate and social changes across the globe.
All of a sudden, we get a cooler environment. Areas that had before been forest, all of a sudden they're savannas, they're open grassland.
The relationship between the oceans and the atmosphere also changed.
The well-known El Nino Southern Oscillation is really a driver for climate on the Earth, undergoes a profound change itself about 4,800 years ago in terms of its periodicity, in terms of its intensity.
Also during this time, there were a number of human migrations.
Populations are moving around. Language dispersals, for example, we get Austronesians moving out of Taiwan and mainland China down to Southeast Asia. We get Indo-Aryans moving out of northern India into Eastern and Central Europe.
Dr. Massey suggests that all these social upheavals and climatic changes can be traced to a great flood that he believes was caused by a comet strike.
We're seeing multiple different things that suggest to us we're looking at a single event at 4,800 years ago as a causal explanation for all of these myths, and it seems to be an oceanic comet impact.
In the course of his research, Dr. Massey found that the geographical distribution of certain mythical motifs were centered on a specific location.
I analyzed 175 Great Flood myths worldwide. And if you map these out, the distribution of these myths, they actually sort of make a broad circle, approximately about 9,000 kilometers away from a central part in the Indian Ocean. And it would appear that this is telling us that there was a comet impact at that location. Looking at the environmental information contained in those myths, such things as the amount of rainfall, the presence of hurricane-force winds, tsunamis, All of these myths together formed a logical picture of something happening at a single point in time.
It is difficult to assign an exact date to the Great Flood, but Dr. Massey suggests that the legends themselves may point science in the right direction.
I was able to hypothesize a precise date for this event by looking at what was in the myths, talking about conjunctions of planets in certain constellations, lunar eclipses, solar eclipse, and conjunction of 4 or 5 naked eye visible planets at a single point in time is a very rare event. And using the software astronomy programs, I was able to come up with a series of events that occurred in 2807 BC.
Dr. Massey proposes that a massive comet, perhaps 3 miles wide, may have crashed into the Indian Ocean 930 miles southeast of Madagascar. According to impact models calculated with data compiled by Dr. Abbott, the fireball would have looked bigger than the sun. The comet would have hit the waves at over 100,000 miles per hour, with over 30 million megatons of energy, generating a mega tsunami that would have devastated coastal lands and human settlements on 4 continents. Torrential rains, created by the vast injection of seawater and impact debris into the upper atmosphere, would have flooded land across the world. Small aerosol impact particles would have been ejected into the stratosphere, blocking the sun's radiation and generating cooler temperatures.
Based on the mythology and based on the archaeological record that we see, I would suggest that perhaps 50% of all people died, either directly as a consequence of the impact and impact-related events, or from starvation in the months that followed.
But mythological accounts are not proof.
Mythology by itself cannot really prove anything when it comes to looking at natural events. We need physical evidence itself.
Scientists are searching for that physical evidence in the Indian Ocean. There, proof of a colossal comet strike may lie hidden in rocks smaller than a human hair. Some scientists think that a massive comet could one day strike Earth, causing a mega disaster. It could have happened before. 4,800 years ago, a comet may have killed more than 50% of the Earth's population. Ironically, many experts believe that comets may have brought to Earth the basic elements that make life possible. During the time it was being formed, the planet was very hot and very dry. So the question that has long puzzled scientists is, where did our water come from? One theory is that comets striking Earth billions of years ago provided the water that would eventually make up the planet's oceans and seas. In 2000, Comet Linear broke apart as it passed by the Sun. Infrared spectrum analysis revealed that the comet was probably made up of water in the form of ice. Some scientists believe that comets may have also dispersed complex organic molecules that could have become the first cell membranes on Earth.
Comets came in and provided much of the water that's in our oceans today and much of the water that's in our bodies today. And comets may also have brought to the early Earth much of the carbon-based molecules that is necessary for life. So without cometary bombardments, it's unlikely that life would have formed on Earth. And so we owe our very existence to these objects.
From the time they were formed, 4.6 billion years ago, comets and asteroids have crashed onto Earth and its moon countless times. Though the moon's cratered surface bears witness to that violent past, Earth's impact craters are less apparent.
In the course of time, the Earth has actually suffered more impacts than the Moon has because it has a bigger area than the Moon does. But we see many fewer craters on the Earth. That's because erosion, tectonics, all these processes that are so active on the Earth but lacking on the Moon have erased the craters.
Even on dry land, craters are difficult to identify.
Impact craters are one of the rarest of the landforms on the Earth. In fact, only about 170 bona fide impact craters are recognized on the Earth.
Of these 170 impact craters, none is located in deep ocean waters, even though oceans cover 70% of our planet's surface. But there may be a number of missing craters on the seafloor. So, how do we begin looking for evidence of a massive comet impact in the oceans? Scientists are tackling the search on many fronts. Evaluating satellite images to identify crater structures all over the world and to locate soil deposits left on the coasts by megatsunamis. Studying computer models to predict the possible effects of oceanic impacts. Using telescopes and space probes to study comets and learn about their composition and life cycles. And analyzing seafloor and coastal sediment samples under electron microscopes. Dr. Abbott began her search for evidence of this catastrophic comet impact in the Indian Ocean.
One reason why I focused on the Indian Ocean was because of Bruce Mass's work, where he's compiled oral histories, and what he determined was that the center of this large deluge event was in the Indian Ocean.
The first physical evidence of this alleged crater was found not in the ocean itself, but on the beaches of Australia and Madagascar. Massive sedimentary deposits called chevrons, some of them the size of Manhattan.
The chevron dune is almost like swash on a beach. You know, you get a wave coming in and it leaves an outline. They're roughly V-shaped. But if you take the V-shaped dune coming in, its trend points back towards the source.
That source could have been a massive impact in the Indian Ocean.
When a big impactor comes in and hits the ocean floor, it doesn't make just a crater in the sea floor, it also makes a crater, an even wider crater in the water. And then what happens is that this water has to fill in the hole and it crashes back in and then it oscillates back and forth several times.
Such an impact would have created colossal waves called mega tsunamis.
So if we're talking about a diameter of 3 miles for the impactor, typically a large impactor coming in like that could produce a wave that was initially about 3 miles high.
By the time they reached the coast of Madagascar, the waves would still have been colossal, creating the chevrons by depositing large amounts of coastal sediment and impact debris.
In the Madagascar chevrons, we found a number of features that we think are materials that are derived from an oceanic impact.
Such as these deep cold water microfossils called foraminifera.
This is a picture of one of these bottom-living foraminifera. And note that all the magnesium, which is in blue, is mostly just right on the outside of the chambers. And we think that this may be due to boiling of seawater in the chambers right after the impact.
But where in the Indian Ocean is the impact crater itself? Satellite imagery may provide the answer. The surface of the sea roughly follows the profile of the sea floor. Underwater seamounts and depressions affect the gravitational pull of Earth on the ocean surface. So we can find holes in the sea floor by measuring the profile of the sea surface with satellites.
I took the chevron dunes and I used their trends to look for possible craters. The direction that the chevron dunes point converges very closely on a location where you have a hole in the ocean floor, a nice round hole.
This hole is 930 miles southeast of Madagascar, an 18-mile wide structure, 13,000 feet underwater, known as Burckle Crater. But a round hole in the seafloor is not sufficient proof of a comet impact. Dr. Jay Melosh, a planetary scientist at the University of Arizona, is not involved in Dr. Abbott's research, but he explains that geological proof of a comet strike would be found at the impact site.
When a comet strikes the Earth at, say, 30 miles a second, it causes huge pressures. In the process of hitting the rocks, those rocks are changed in a way that no other process on the Earth can. If we can find that changed mineral in the impact site, we're sure that it's an impact.
Ships crisscross the world's oceans, gathering deep seafloor samples. Every one of those red dots represents an area where scientists have collected deep-sea core samples, soil samples extracted from beneath the ocean floor. Thousands of these cores are stored at the Lamont Doherty Earth Observatory in New York.
This core is from the southwest Indian Ocean. It's from the vicinity of Burckle Crater, and you can see that it's a fairly dark color. The dark color is because it's from quite deep water, about 4,800 meters deep. This is enough, I think.
Okay, so you want me to look for splash?
Dr. Abbott analyzes the seafloor samples under a scanning electron microscope with Drexel University's Director of Microscopy, Dee Brager.
When comets or asteroids hit the bottom of the sea, they tend to vaporize or melt material either from the rock that they've hit or the impactor itself, which condenses into submicroscopic splashes of metal that are shot into grains of sediment, into microfossils, into whatever is down there at the bottom of the sea in microscopic amounts.
What we found in this sample were little bits of crushed rock. These pieces of rock looked as if they'd been hit with a hammer. And then on the rock, we found tiny bits of metal, nickel-rich metal. And nickel is not very common on the Earth, so we think that this nickel is bits of the impactor that were vaporized.
I don't necessarily see splash yet.
Still, Dr. Abbott needs more evidence to prove that Burckle Crater was created by a comet impact.
What we hope to learn from this piece of deep-sea sediment is what's the source of the impact that produced Burckle Crater. We really don't know enough about comets and asteroids to be sure right now if we can tell.
We may not know enough about comets, but we know they're out there, on the fringes of the solar system. Billions of them. And they are just waiting for a passing star's gravitational force to launch one on a collision course with Earth. Ever since man first noticed these fiery objects in the night sky, comets have inspired wonder and fear.
People have been observing comets for thousands of years. They fly by, we look at them, and we say, ho, ho, ho! You know, something is happening that's very unusual.
Their enigmatic history dates back to the dawn of our solar system, 4.6 billion years ago. Our solar system emerged from a cloud of gas and dust in motion. From it, the hot inner solar system planets, Mercury, Venus, Earth and Mars were formed, leaving the leftover rocky pieces of that process, the asteroids, in orbit just beyond Mars, in the asteroid belt. The cooler outer solar system planets formed, Jupiter, Saturn, Uranus and Neptune, yielding as remnants the icy objects we call comets.
There's three basic parts to an active comet. The tail can be either gas or dust, and it's typically millions of miles in length. The coma or atmosphere can be hundreds of thousands of miles in diameter, but the nucleus typically is only a few miles in diameter, and that is the heart of the comet, the ices and the dust in solid form.
Billions of years later, thousands of objects linger in what astronomers call near-Earth proximity, That is within 120 million miles, which is close on a cosmic scale. There are two types of near-Earth objects that concern astronomers.
We have the asteroids, which are far more numerous than the comets, but we can discover them 20, 30 years in advance of any threatening impact. The comets, on the other hand, are a different story.
Unlike the more predictable asteroids, comets may appear at dangerously short notice.
If we do find a comet that's on an Earth-threatening trajectory, we would only have a few months to deal with it.
A comet impact in the near future is very unlikely. But the potential threat is made more critical by how little we know about these celestial missiles.
We know a lot about asteroids from studying meteors for many, many years, but there's not nearly as much data on comets or how they're put together physically.
As mysteriously as they appear, comets do not materialize out of nowhere. They seem to have two cosmic homes. The so-called short-period comets, such as the famous Halley's Comet, come from an area just beyond the orbit of Pluto, called the Kuiper Belt.
The Kuiper Belt comets, we have much greater luck tracking them, knowing where they are, having them repeat, so that we are, okay, this is the same one we've seen 5 years ago.
But there is a more intriguing collection of comets, which originates much further away from Earth, and could pose a greater hazard.
The second source of comets is the so-called Oort cloud, which extends out to the very edge of our solar system, halfway to the nearest star. And this is a spherical distribution of comets.
There are billions of these so-called long-period comets in the Oort cloud.
The Oort cloud tends to send comets in at random. They come in from all directions, and we never know where they're going to come from and when they're going to come by. And most of those Oort cloud comets come in and go out, and we never see them again.
Their size and speed make them capable of multi-megaton impacts, powerful enough to cause a mass extinction if they hit Earth.
Let's think of ourselves riding along on the comet as its lifetime progresses. It starts out in the Oort cloud, and at that distance, of course, the sunlight is so remote that these ices are still rock hard, and so you've got a jet black icy dust ball in space that slowly is perturbed out of the Oort cloud by a passing star, perhaps.
Initially, some comets travel slower than most aeroplanes.
It's a million-year voyage, and the vast majority of it is spent in complete darkness and complete deep freeze of space.
Near Jupiter, the comet starts to feel the sun's heat and wakes up, transforming into a high-speed missile that accelerates to over 70,000 miles per hour due to the gravitational attraction of the sun and the planets.
At that point, the ices, mostly water ice, start vaporizing. The dust particles within the vapor stream start reflecting sunlight, and that begins to show itself as what we call a comet.
This process makes it difficult to study the composition of the comet itself.
The problem with studying the heart of a comet, the nucleus, is that once the comet gets into the inner solar system where we can get a good look at it, Mother Nature starts throwing off gas and dust from these cometary nuclei, and it effectively hides the cometary nucleus. And so to understand what is the heart of a comet, you have to send spacecraft.
A number of missions to study comets have been launched since 1978. But two recent missions have been the most successful.
The Deep Impact mission actually ran into Comet Tempel 1 in July of 2005, and the Stardust spacecraft flew closely past Comet Wild 2 and brought back to Earth some of the dust from that comet. So those two missions have really enabled us to understand the nature of the cometary nucleus.
The findings revealed information about its composition.
The fact that they're jet black, they're icy dust balls covered with a layer of silicate dust, talcum powder-like dust. Objects that are a few miles in diameter, muffin-shaped, easily broken apart, very fragile objects, and the remnants of the early solar system formation process.
Even though comets may be fragile, Their speed, size, and unpredictability can make them very lethal threats. Therefore, scientists hope that the next mission will reveal even more about these cosmic stealth missiles. The new European mission Rosetta is already on its way to Comet Churyumov-Gerasimenko. When it arrives in November 2014, it will perform a series of maneuvers culminating in the first landing on the surface of a comet in flight.
We're going to fly out and meet the comet near the orbit of Jupiter and escort the comet in all the way past the sun and out on its outbound leg, getting a chance to study it for months and months, watching it as its activity unfolds.
But before we can identify which comets may pose a threat to our planet, we have to find them.
Comets are discoveries. They are things that you're not expecting to find in one particular spot or another. So having a telescope that lets you look at a large area of sky at once is actually much more beneficial than something, say, like the Hubble telescope, which is really only staring at a very tiny piece of sky, but in a lot of detail.
New wide-field telescopes will help us keep watch on the skies. The Large Synoptic Survey Telescope, LSST, will see first light in 2014. It will provide digital imaging of faint astronomical objects, such as distant comets, with a 3,000 megapixel camera from its vantage point on Cerro Pachon in Chile.
The LSST will actually be able to take a complete snapshot of the sky every few days, and it will keep repeating that over and over again. So by stacking these full sky pictures up one on top of the other, astronomers can look to see if anything is moving.
On the 7th of August 2006, using this 4-picture time-lapse sequence, astronomer Robert McNaught discovered the comet now bearing his name. The faint and fuzzy spot moving within the circle is Comet McNaught.
Once we find these objects in the inner solar system, we have to compute orbits for them to be able to predict where they'll be in the future.
Asteroids are easier to find and track because they are inactive, and their orbits are affected only by neighboring planets.
Comets, on the other hand, have an additional problem with them because when they get into the inner solar system, they start thrusting toward the sun, and that pushes the comet in the opposite direction.
This may modify their trajectory as they fly, like a rocket engine might, making it difficult to calculate their orbits accurately. Another problem is that comets are virtually invisible until they reach Jupiter and start ejecting gas and dust.
And it only takes 9 months to get from the orbit of Jupiter to the orbit of Earth. It would take a few months to determine its orbit and to determine that it is a threat, and then we'd only have a couple of months to do something about it.
It could be worse. Some comets are discovered closer to Earth. Comet McNaught was spotted in August 2006, only 4 months before it passed by Earth's orbit in November that year. Scientists are working on ways to deflect or destroy an asteroid on a collision course with Earth, from nuclear weapons to gravity tractors. But today, there is little we can do to defend ourselves against an incoming comet.
In the unlikely event that we do find a comet that's on an Earth-threatening trajectory and it's large, say 2 miles or larger, there's not a great deal we can do, frankly. That's the bad news. The good news is it's not very likely to happen.
To date, David Levy has discovered 22 comets from his observatory in the Arizona desert.
Every time a comet is discovered, there's always a little hiccup that happens. Is this comet one that can endanger the Earth? The one that I found a few months ago is one that comes by every 5 years. And there's a chance that at one of its passages, it could threaten the Earth. We're not sure about that. We don't know it as well as we'd like to.
In 1992, Levy, together with Eugene and Caroline Shoemaker, discovered the now famed Shoemaker-Levy 9 comet that collided with Jupiter in 1994.
The important thing to remember about comets is that they're like cats. They both have tails, and they both do precisely what they want to do. In some ways, comet hunting is an art, not a science.
From the Indian Ocean 4,800 years ago to the Pacific coast of San Francisco today, we can only imagine what a large comet strike would unleash if it happened now.
There's no doubt that there's going to be dramatic effects on the Earth, on the Earth's surface, on the climate, and that are going to affect life.
A 3-mile wide comet strike could kill millions of people. Exactly how that would happen is hard to predict.
Fortunately, we've never seen a large comet strike the Earth. But we can work out what happens by using the laws of physics. We can take those laws, distill them down into a computer program, and predict what events will happen when a mile-wide comet slams into the Earth and makes a crater perhaps 20 miles in diameter.
The Los Alamos National Laboratory in New Mexico is looking ahead.
We have, in fact, right now, very large three-dimensional computer code capabilities that can help us as a nation improve our detection, our assessment of catastrophic impacts, such as a cometary impact off the coast of San Francisco.
With data compiled by Dr. Abbott and damage estimates based on an impact effect calculations program, we can depict the scenario of a 3-mile wide comet crashing into Earth. With little warning and no way to stop this intruder, millions of people could find themselves in the middle of a global mega disaster. Could a massive comet crash into the Earth again? This science fiction scenario could become a devastating reality. Based on data gathered by Dr. Dallas Abbott and calculations performed with the University of Arizona's Impact Effect Calculator program, it might unfold like this. A comet started its journey millions of years ago on the distant edge of our solar system. It is now near Jupiter. The stealthy ancient traveler, awakened by the approaching sun, starts jetting dust and gases from its icy nucleus. It is 4 months away from its target, Earth. 2 a.m. at the Mauna Kea observatories in Hawaii. Astronomers identify the faint optical signature of what may be a new comet, as dim as Comet McNaught's image when it was discovered in 2006. Other astronomers around the world confirm the sighting. It is a new comet, and it is approaching Mars fast. The Minor Planet Center in Massachusetts begins to calculate its orbit. It will take scientists at least a couple of months to calculate whether it could hit Earth. Nearing Mars orbit, the traveler is now a dazzling sight with a growing tail of light, dashing towards the Earth at over 50,000 miles per hour. It is confirmed. The object is a long-period comet with a trajectory that will cause it to hit Earth in 30 days. Warnings are issued across the world, but time is running out. Governments and international space and military organizations scramble to decide on a course of action.
It's technologically much more difficult to deal with a comet than it is an asteroid.
Shooting it down is not an option. It may compound the problem by creating a collection of fragments. Diverting its trajectory with a spacecraft is not possible. There is not enough time to prepare and launch such a mission. Now, about 2 million miles away from Earth, the comet speeds at more than 100,000 miles per hour. Scientists narrow the probable impact zone to an offshore area near San Francisco. The comet is about to collide with our planet's most effective shield, the atmosphere, but it will provide no defense at all.
So a large comet, several miles in diameter, would simply punch right through the atmosphere, and it wouldn't matter that the comet is fragile and underdense and porous.
Bridges and freeways are jammed as a panicky population tries to flee the city. but it is too late. The 3-mile-wide comet hits the Pacific Ocean 100 miles west of San Francisco. With more than 30 million megatons of energy.
When it impacts the ocean surface, it is going to essentially vaporize the water almost immediately.
The impact unleashes a blast of thermal radiation towards the city.
You're talking about minimum of temperatures around 1500 Kelvin. So anyone who's outside when that event occurs would essentially be vaporized almost.
Wooden structures, dry grass and brush all ignite in a flash. Flames burst out around the city. As over 7 million people in the Bay Area are scorched by the lethal heat. A 9.0 earthquake caused by the comet's impact shatters structures and buildings all over San Francisco. The Bay Bridge collapses. The Golden Gate Bridge yields to the inexorable power of nature. Entire districts in the city cave in as the ground liquefies under their foundations. Cracks appear in the ground, transforming the landscape. As the minutes tick by in slow motion, 3-inch fragments of debris from the seafloor pummel the defenseless city. In the midst of chaos and destruction, a moment of eerie silence precedes the sonic bang. The deafening air blast breaks through at more than 4 times the speed of sound, destroying whatever had been left standing.
The resulting shock wave and the overpressure produced by that shock wave could lead to the destruction of a vast number of buildings in San Francisco. You're probably looking at most buildings being destroyed.
Glass windows shatter all over the city. Highway truss bridges collapse. Cars and trucks on the roads are tossed about by high-speed winds. And now, this landscape of utter destruction is about to be washed over. The comet's impact has generated a massive mega tsunami just 100 miles offshore. By the time it hits the coast, the enormous wave swamps the Golden Gate Bridge, crashing into the bay and flooding the city. It also travels west toward Hawaii at more than 500 miles per hour.
More than likely, if this happened in today's world, most of the cities along the ocean would be wiped out.
The city of San Francisco has been annihilated. The comet's impact has sent a plume of water vapor and solid particles into the air, injecting them more than 9 miles into the stratosphere. Thousands of miles away, fires from impact fragments and torrential rains ravage lands in South America, Canada, and Eastern Asia. Valleys and lowlands flood, decimating communities and destroying entire regions. The immense amount of water and heat injected into the atmosphere creates storms of biblical proportions.
You could get the formation of a super hurricane. Super hurricane, you can imagine, is like a Category 5, like Katrina, but 100 times worse and maybe 3 times bigger than Katrina. Once that hits a region, it would produce so much rain. You could get like a 1 in a 10,000, 1 in a 100,000 year flood.
But the mayhem is not over yet.
As the plume spreads across the globe, you would get further cooling. This could induce, in some situations, Earth going into a mini ice age. And that would probably be the worst case scenario in terms of long-term climate effects, is a mini ice age.
It would take decades, if not centuries, for the planet to recover from the catastrophic environmental consequences of the impact. As we did 4,800 years ago, humankind would probably survive this global disaster, but the world would never be the same.
Should have another impact within about 1,000 years.
To date, scientists have found only about 170 impact craters on Earth, of which only 2 were caused by substantial strikes within the last 2.6 million years. Finding more large impact craters could indicate that a major comet strike within the next millennium is possible. Dr. Bruce Massey and his colleagues think that recent large craters are to be found in the oceans.
Currently, there's over 170 known impacts that have been absolutely validated by physical methods. Of those impacts that have been documented, there are none in the ocean. And yet the oceans cover more than 70% of the Earth's landmass. So we are missing a large percentage of recent impacts because they occurred in the ocean.
According to Drs. Abbott and Massey, one of those missing impacts may have happened 4,800 years ago. They believe that its catastrophic effects could have inspired the story of the Great Flood, found in the Bible and other accounts. Throughout the ancient world, different cultures, from Europe and Asia to the Americas, had legends of a great flood.
Because we only have truly one universal myth, that's the myth of the Great Flood, it was my hypothesis that perhaps it was evidence of a globally catastrophic event.
According to Dr. Massey, this globally catastrophic event may have been the impact of a comet crashing into Earth. Many of the legends describe supernatural creatures or fiery objects appearing in the sky around the time of the flood.
Sometimes these things are described exactly like comets, as flames in the sky. But at least 33 of these myths talked about creatures that were suggestive of a comet.
Dr. Massey sees further evidence of widespread disaster in a series of global changes that occurred 4,800 years ago. At that time, advanced societies were already developing in many parts of the world.
This was already the time of the first dynasty of pharaohs living in Egypt, very advanced civilization.
Then, around the year 2800 BC, there was a series of sudden climate and social changes across the globe.
All of a sudden, we get a cooler environment. Areas that had before been forest, all of a sudden they're savannas, they're open grassland.
The relationship between the oceans and the atmosphere also changed.
The well-known El Nino Southern Oscillation is really a driver for climate on the Earth, undergoes a profound change itself about 4,800 years ago in terms of its periodicity, in terms of its intensity.
Also during this time, there were a number of... From the very edge of our solar system, a comet speeds towards Earth. It cuts through the atmosphere and plunges into the Pacific Ocean near San Francisco, creating a blast more powerful than any thermonuclear weapon.
Anyone who's outside would essentially be vaporized almost.
It causes a mega tsunami that devastates America's west coast.
Most of the cities along the ocean would be wiped out.
Over billions of years, comets have struck our Earth countless times. And it could happen again.
If it's a large comet, frankly, I'm not sure we could do anything about it.
Through history, comets have been seen as bad omens. People believed a comet heralded the assassination of Julius Caesar, and another foretold the Black Death in medieval England.
During the Middle Ages, comets were thought of as warning signs, missiles shot at a sinful Earth from the right hand of an avenging god.
Some cultures depicted them as blazing swords, slashing the nocturnal sky as an expression of divine wrath. But by the 17th century, Astronomers were beginning to understand the true nature of comets as physical objects rather than by thousands of comets and asteroids. Scientists think that such impacts may have caused at least 2 of the 5 global extinctions. The most recent, 65 million years ago, is thought to have killed more than 75% of the living organisms on Earth, including the dinosaurs. These major cosmic strikes seem to occur at very long intervals.
The time between impacts depends very much upon the size of the object impacting. For example, an object a kilometer in diameter may hit once every 10 million years, whereas objects 10 meters in diameter might hit the Earth a couple of times a week.
But some scientists now suggest that during the last 10,000 years, the so-called Holocene epoch, Earth may have suffered a series of more frequent, large, catastrophic impacts. They argue that if a number of newly researched geological structures can be confirmed as comet impact craters, this would indicate that comets have struck Earth more frequently than previously thought. And that we may be due for another devastating impact.
If we are able to prove that we have this many craters within the Holocene, it implies that there should be a large impact on the average of about every 1,000 to 3,000 years. And so we should...
Supernatural creatures or apparitions. Using Isaac Newton's principles, astronomer Edmund Halley calculated the orbits of 24 comets.
Halley was the first to note, along with his colleague Newton, that comets are celestial objects. They're in orbit around the sun just like the planets, except they're on very elongated orbits, so they can cross the Earth's orbit once on the way in and once on the way out.
Halley boldly announced that 3 of them, seen in 1531, 1607, and 1682, were in fact the same comet on its periodic visits to Earth. He predicted that the comet would return every 76 years, and he was right. Halley's comet did return in 1758, as it has done roughly every 76 years since. Halley's discovery altered the status of comets, from mystical omens to real and physical threats.
The fear of comets was sort of transferred from a sign of an impending disaster, some sort of an apparition, to objects that actually could hit the Earth. So we went from warning shots to actual missiles.
One of those missiles might have changed the world 4,800 years ago, and experts think that another deadly missile could strike the Earth with very little warning. Since its birth 4.6 billion years ago, Earth has been pummeled